Now in part B, we are going to analyze the system of equations simultaneously, 2 by 2. For example, let me go with the easy example. We'll just go with the analyzer and we will go with some observation of the system of equations. Let's say, for example, you have x plus y equals to 5 and x minus 1 equals to 7. I just chose the easy system of equations, so we know how to solve it. We know that if you solve here, there are different ways, which way you like. So it will be x equals to 6 and y will be minus 1. So shortly you can write 6 and 1. Now, this system of equation has the same solution if I just change their places. The second equation, if I write first, and if I put the first one as the second equation, it will have the same solution, right? So there is no big difference. I just change their places. So here we are just observing, making observation. It will have the same result. If you multiply any of them by any number, it will again have the same result. Let's say you multiply the first one by 3. So it will be 3x minus 3y equals to 21, and the second one do not change. Now, if you see, these one again will have the same solution. It's 6 and 1. If you multiply first and second by any different number, let's say you multiply first one by 5, it will be 5x minus 5y equals to 35, and the second one, let's multiply by minus 2, minus 2x minus 2y equals to minus 10. These again will have the same system or the same solution. Maybe if it's not easy for you to see, you can easily use decimals or go and calculate. It will give you the same result. I will tell you one more. If you, keep the first one. Okay, let's keep the first one. Okay, let's go to the original, x plus y equals to 5. And let's add these two. Let's add these two. I multiply first one by a number, second one by a number, and now I can add or subtract. Let's add them. It will give us what? 3x minus 7y equals to 25. Now here's one more thing. These one will have again the same solution, 6 and 1. Because we are dealing, maybe you can observe it or think as geometrically, we are dealing with the lines. You are just multiplying line by a number. It doesn't change. When you add these two numbers, it will give you again the same solution. So these are just some examples for you to analyze it. Now, why I did explain it, we did discuss augmented matrix last time. The same thing we are going to do with the coefficients. Actually, if I rewrite these system of equation, what do we had? X plus y equals to 5, x minus 7 equals to x minus y equals to 7. Is it correct? Yes. Is it the same equation? Yes, it is. Now, if I write in an augmented matrix, I will just consider the coefficients. So the coefficient of x is 1, 1. Here I will put the results 5 and 7, and I have 1 minus 1. So these one will have the same result. If I, here I will put rows here. If you interchange the rows, row 1, if you interchange row 2, like we did discuss before, it will give you the same result. It should give you the same result. I have difficulty with putting bracket 1 minus 1, 7 first, 1, 1, and 5. I just interchange the place, and this one again will give me the same solution. Here I put the coefficient like last time here. And again, if you want to multiply the row by a number, you just need to indicate it in the row operation. So you say that, let me multiply first row. Okay, here if I discuss, okay, let's go from here. I'll multiply the first row by 3, and I will replace in the first row. So I will multiply and I just replace it. So it will be the new matrix will be, you just multiply the first row by 3, it will be 3, 3, 15, and you are replacing it. Means that this arrow means I will put that number there. So 1 minus 1 and 7. Again, it will give you the same result. If you want, you can, as we have done it here in the last one, let's multiply the first one by 3 and second one by 5 and replace in the first place. So what I'm going to do, I will put the operation 3 multiplied by first row, add to the 5 multiplied by second row, and change it to the first row. Put everything this row to the first row. So how it will look like, it means that you are not changing the place of the second row. The second row will remain the same. So what I have as a second row, 1 minus 1, 7. I'm not making changes. I'm just making changes in the first row. So what kind of change I'm doing? So it says if I go like in your book, multiply first row by 3, so it will be 3, 3, 15. Add them to the 5 multiplied by the second row, so it will 5 minus 5 and 35, right? And we need to add them up. If you add them up, it will give you 50 minus 2 and 8. So you change the first row, as you say here, 8 minus 2 and 50. So this one again will have the same solution. So I kind of wrote messy here. So if you are going to use this one, first you need to indicate what are you doing. If you are going to go for the second matrix, you have to explain your way, the method, what you are doing. Are you interchanging their place? Are you multiplying by a number, some row? Are you adding or subtracting rows? And where you are making changes, this one is important. So this one again, this part B is just the method, and the first part, in part B, then we are going to use all of them in part C for 2 by 2 matrix. Then when we understand it, we will go for 3 by 3 system of equations.